Bruh, Xenon was my girl.
What are we talking about?
Xenon of the space station.
Yeah. It's a Disney thing.
It's a Disney girl movie.
Yeah. Okay, on that note, let's do a couple of things if you want to. I'll leave the options up front to you. We can go over these two, which should be very straightforward for those of you that looked at it. Today's lesson probably will be a two-dayer, even for us, using the full time. It is the single most important lesson of second semester.
Good, and I'm not missing it.
Right,
You're
here
going to.
today and tomorrow.
Oh.
Use substitution. Today is mainly learning the lesson, and tomorrow is doing lots and lots of practice problems and fine-tuning the technique. So if you are here today, you'll get it.
Okay.
Tomorrow is me showing you, we just practice, and maybe show you a couple of tricks. Maybe they'll try to fool you with some things. All right, if y'all would like to go over it, we can do that. If y'all want to skip these, it's entirely up to you. I'll let you decide. If you can do these two, this sheet right here, then you've kind of mastered particle motion.
Different.
Okay. You want to do one of them maybe? They're both kind of the same thing. Let's do,
I think everyone is because no one actually speaks.
let's do the 2003, not the 3B, but 2003, so this one right here. The one about particle moving on the x-axis so that you have velocity is negative t plus 1 sine of t squared over 2. Let's just do that one to make sure we're cool with particle motion, and then we will move on into today's.
Xenon girl of the 21st century, that's what it was.
Why are you looking this up
You want
now?
to know?
1999, that's a good movie.
That was.
They had a sequel too.
I was.
There was a
two.
sequel?
Wow.
You didn't know there was a second?
Wait.
No, there was a sequel.
Yeah, you didn't know there was?
Yeah, no, I knew that.
Of course
I was
he
saying
knew
you
it
love
was
the
a
first
sequel.
one.
Wait, maybe I
and
did
the
see
second
it.
one.
Is it space station?
You
It
never
looked like
did
some,
Space.
kind of.
The first one had the guy with the spiky hair, he's supposed to be on the school and all that sort of thing, and that was the song he was singing.
It was called Xenon the sequel.
Oh man, I hate people.
Bruh. That was it.
That name though.
Xenon?
Xenon the sequel.
They had to say that?
Yeah, we're kids. We go with anything. Of course.
It's Disney, they're
Are we
cool.
recording yet?
Yeah.
Yeah.
We are, okay.
No, we're talking about
Disney movies.
Disney movies are great.
Okay.
the older ones.
Alright, so we are doing, as a warm-up, we're doing the practice problem 2003, number 2. This is the one that starts with the given velocity. So we have negative t plus 1 sine of t squared over 2. By the way, the very appearance of this just kind of screams calculator. That right there is virtually impossible to work backwards. Derivatives are cool. Working backwards would be next to impossible, even with the techniques we're going to learn today. So I would say have a calculator handy beside you, ready to go, because I'm going to need y'all's help with that. They also say at time 0, the particle is at position x equals 1. So I'm going to say s of 0 is 1. Okay? This is just given along with it. That also leads me to believe that I'm going to have to take an antiderivative and work backwards. That's kind of what I gather. They start with velocity and they give me information about position. So before I even set pencil to paper, I already have the mindset of how to approach this problem. Part A, find the acceleration of the particle at t equals 2. Is the speed of the particle increasing at 2, y or y not? Speed is a tricky one. Speed gets kids a lot. Alright, so part A. First, find the acceleration of the particle at time 2. Okay? 2 ways to do this. Number 1, you could take a derivative by hand, plug in the number 2, and go from there. Alright? Number 2, because this is a calculator question, you could just type all that garbage into your calculator and
It works.
go from there. So, here's why I'm thinking by hand is not the best choice in the world.
Not really.
We're going to plug in 2, and while 2 is great here,
Yeah.
2 doesn't give us a value. He was saying somewhere in that corner, I think. You
Yeah,
talking about the water spot? I think that's what he was talking
Yeah.
about.
Is it leaking out now?
No, not now.
You just got a water
It's just
spot.
the color on it right now, yeah.
Our beautiful closet.
Yeah, it's falling apart. Our
There's a
little
little bit
slice of
over there,
heaven.
Yeah.
We just spotted one over here too for me.
Okay, let me see.
That one's smaller but looks nastier. We're taking a moment now to find water spots on the ceiling.
Okay, this one right here, one,
Oh, I didn't even see that one.
Yeah.
How did I not see that?
Good eye.
three.
I went too hard, I saw that right past it.
Yeah.
It's really stinky to just start sleeping in here one day.
Oh, that's fine.
No, it'd be
All right,
funny if
thank you,
it-
guys.
Yep, thank you.
Drill be going forward.
Alright, I'm gonna leave it to you to go ahead and type this into your calculator, so I would suggest y'all practice with the calculator. Okay, this is again underneath math, and, well, this one, because you're going to acceleration, it's gonna be math 8, because we're taking the derivative. So I would just say A of 2
Oh, good, it's not in German this time.
is yeah, we fixed it, yeah, is approximately equal to, drum roll please.
Oh, you want me to look this up?
Alright, anybody to do it, first person to get it right, and then everybody else needs to confirm it.
I'm lost.
Y'all do remember how to type it, the math 8, you do the function, and then it would give you a value, like what you wanna plug in.
You do put like versus D. or-
One
D, where it says D whatever, you need to put the same letter that you used in the original problem.
1.5875.
Okay, give me 3 decimal places.
587. 588.
Okay.
588.
Alright, by the way, the calculator, hang on. 5875, okay, so here's the deal with the calculator. On the AP test, they will either take the rounded answer or the truncated answer. So if you had put either 1.587 or 1.588, you would have gotten credit on that,
One, this will be better.
okay? So either truncate it, just cut it off, or round it, whichever one makes you happy.
Sorry, yeah.
Huh?
The calculator's not that, like, it's not perfect.
It's a guess anyway, and 3 decimal places is usually accurate enough for whatever you're trying to do, so yeah, they don't really care. By the way, I get used to this notation. First, the A tells me I'm talking acceleration. The 2 tells me I plugged a 2 into it. You do not need to show where the derivative came from, because we didn't actually take the derivative by hand. If this were non-calculated, then the first thing you should have done was taken a derivative and then plugged in 2 to get whatever answer you got. How much do you think that one's worth? By the way, part A, B, C, D, so you got 4 parts to split 9 points.
That's either 1 or 2.
I'm saying 1 point for that answer,
Yeah.
okay? There is a second part though. Is the speed of the particle increasing at t equals 2? Alright, speed's a funny thing. Speed is the absolute value of velocity.
Yes.
Where velocity gives you both a magnitude and a direction, speed only gives you a magnitude, doesn't tell you whether you're in forward or reverse.
Now, it's
Okay.
saying if the speed is positive.
No, if the speed, your speed is always positive, by the way.
That's what I'm saying.
What it's asking you is, am I speeding up or slowing down? So here are the 4 things. Let's imagine a car, all right? This to the right, forward, reverse, all right. Possibility number 1, I am heading forward with my foot on the gas. Am I speeding up or slowing down?
Speeding up.
Speeding up. I'm moving forward with my foot on the brake.
You're slowing down.
Right, but I'm still moving forward.
Yeah.
Do you understand that? Alright. I'm in reverse
The acceleration.
with my foot on the brake.
You're
Still
slowing down.
slowing down, you're slowing down.
I am in in reverse with my foot on the gas.
You're speeding up.
Good. Alright, so you understand the 4 things that could happen.
Pretty
What-
much, we still need acceleration, but it doesn't really matter which.
It ties to velocity. Here's the thing. In order to answer these speed questions, you have to compare the velocity with the acceleration. If your velocity is positive, which direction are you heading?
You're heading, you're getting
Either
faster.
forward, right, or up, depending on what the context of the problem is. If your velocity is negative, you are heading left, down, or in reverse,
Negative, yeah.
whatever, okay? Acceleration's funny. If your acceleration is positive, that means your velocity is getting bigger,
Yes.
okay? In forward, that makes perfect sense. In reverse, it throws people off. Okay. Velocity, just a side note here. Velocity positive, acceleration positive. What's my car doing?
It's getting faster forward.
Faster forward. Velocity positive, acceleration negative.
Slowing down, going forward.
Slowing down, slower forward. Okay, velocity negative, acceleration positive.
Faster, backwards, or down.
Slower backwards. Why?
Because it's still, the acceleration is still positive, so it's still curving. It's not, well,
What does velocity negative mean?
it's heading down.
Okay,
or
so
left.
pick a number like -10,
So
okay? What does acceleration positive mean?
it's curving up, so.
My velocities are going up. So I went from say -10 to -9 to -8, which is going up. So if my velocity is going from -10 to -9 to -8 to -7, I'm still in reverse, but I'm closing in on 0, so I'm slowing down. I'm backwards, slowing down. Velocity negative, acceleration negative.
It's speeding up.
I am in reverse and my foot is hard on the gas.
Yeah.
Okay, so I am speeding up or faster, backwards. So in order to answer this question, am I speeding up or slowing down, I need to look at not only acceleration, but velocity as well. So we have acceleration. By the way, acceleration is positive. That does not tell me speeding up or slowing down. I need to compare it to velocity. So what is the velocity at 2? Again, calculator, plug it in, yada, yada, yada. So go ahead and do that. I can already tell you, I think it's gonna be positive. I'm sorry, negative. Yeah, that's gonna be negative.
Negative, yeah, it might be negative.
Was
The
it
first
negative?
part's positive, a negative, and the second part's negative, so -2.7 to say.
I'm sorry, negative 2
7
Uh-huh.
to 8.
Got it, good. So because the velocity is negative and the acceleration is positive, am I speeding up or slowing down?
Velocity is positive, no, velocity is negative.
You're slowing down.
I am slowing down. I'm in reverse and slowing, you don't need to tell them you're in reverse, but I am slowing down. The particle is slowing down. And you need some kind of justification. All right, you got A, acceleration at 2, you got velocity at 2, and you tied those two things together in an answer. I'm thinking 3 points. 1, 2, 3, tying it together. okay? That means the other questions are gonna be short. One of them's gotta be worth 1 point at least, if not more. So this one, probably right here, was worth a good chunk of the points, the rest of them are not gonna be nearly as exciting.
Which kinda sucks, 'cause that was pretty, not
That was a good one, yeah.
intensive a question.
The way I teach, the way I do this, I'm very sentence driven. This is the English sentence. You could have also said velocity is negative like that. That's more math sentence if you wanna go that route. Not the way I really teach it, cause I kinda like for you to be able to justify it, but, both of these would be acceptable if you had used these notations here. Part B. Find all the times in the open interval from 0 to 3 when the particle changes direction.
Okay.
Well, shoot, that's easy.
So equals,
Why do you make it so hard?
oh,
Okay, talk to me about how we would do this normally. Okay, alright, what is the if you said equal to 0? Set the velocity equal to 0.
yeah, let's just plug into the calculator.
Whatever. What, define the word equals 0?
Yeah.
Wait, I can do you one better. Set it equal to 0, find critical numbers, and then make a number line and test it, right?
Okay.
Alright, why don't you just do this? Why don't you just graph it?
Yeah, that's what I was gonna
Graph
say.
it.
Graph the velocity and then see where it actually changes from being above the axis to below the axis or vice versa. Set your window. What do they want, 0 to 3?
Mhm.
Set your window from 0 to 3, graph that bad boy, boom.
Oh.
Ease, points, calculator.
And all the times t on the open interval when the particle changes direction. I can't wait to see you get the full points for this.
No wonder my grandpa called it.
Anybody got a graph it, did you?
Oh, okay.
These are not my problem.
Where am I?
Your,
Okay.
your, your head
He's just having some problems.
is so magnificent, but it's also
Oh, perhaps you should put out the sheet of paper that I gave you Friday to.
That's the problems.
let's not talk about that right now.
Oh, look, here's one right here.
Really?
Did you do a window from 0 to 3?
Yeah.
Cool.
I had to fix my window because someone had changed it.
I'm so sorry.
And then convert was on it. There was
Are you in
lines.
radians or degrees?
Um,
You're in radians, good, okay. Alright, looking at that graph. Go.
two. Wait, that
Once.
counted as one?
By the way, I can tell you an easy one right here. If you were to set this equal to 0, this would give you -1 as one of your turning points, but unfortunately, that is not inside your interval 0 to 3. So the other spot, the 1 spot, is right
Between 2
wherever
and 3.
that goes, yeah. Now, it says, find the time. Not how many times,
Yeah.
but find the time. So now what?
Now you gotta go to good old,
Between,
second trace.
Second trace, yeah, don't guess, don't sit there and trace
Well,
it.
thank you, yeah, second trace.
Second trace, 0.
Yost.
You know how to do this, somewhere to the left, somewhere to the right, guess. Alright, thank
Do you
you.
want to actually guess, or you just press the same number? 2.506.
2.506.
Or 7.
Which one do you want?
2.507.
Okay. You rounded, I'm assuming it was 6 something else.
It was 6.6.
Okay. At time, okay, let's get full credit. Because
Because we put it in the graph that way. They- we
no,
graphed
it's
it.
because
what
the,
were you
calculations-
looking for?
Oh, because the velocity
Does it change
changes from
sign?
positive, changes sign.
Just say change signs, yeah, and be done with it, because that's where because the velocity
If they want that, they can say. But nice picture.
change signs there.
And once you're done with, and if you get finished fast, you can draw a nice picture of a calculator and say thanks for pouring.
By the way, there is one extra spot at 0,
But that,
okay? That's the red herring, we can't use 0 because we technically, it hasn't changed before 0 on that one. So starting at 0, from 0 on, that's the only place that it changes sign.
because from there it starts at 0, it's from 0 to negative, so you.
Right. 0, I think at 0, plug in 0, you do get 0, and then from that point, I think it did right, it does go below the axis from there.
So, but.
And this is where it crosses back over to positive. Cool, all right, how many points do you think that one's worth? 1? All right, that means your 1 point comes from the answer and the justification, okay? Well, if you're gonna say 2, then the 2 would be 1 here and then 1 for a reason. However, if it's 2, then we're up to 5 points
Yeah,
now,
so it's like 1 because of how much that one took up.
okay? So maybe let's look at C and D, see how bad they are. Maybe they are only worth a point or
C.
2 each.
Find the total distance traveled by the particle from time t to equals 0 to t equals 3.
3, all right, total distance traveled, go.
The one.
Okay.
Never should get that.
Also a calculator question.
Yeah.
Total distance traveled, so we want.
Please remember this from Friday, the difference between total distance traveled and, not Friday,
Net.
Thursday, yeah, and net.
We want
Okay.
total, that's positive. So we need to take an anti.
Correct. It's a position question, and we have velocity, so we're gonna work backwards from velocity to position. I am gonna go from 0 to 3. Is that what they wanted, 0 to 3?
Yep.
Okay. Total distance traveled is absolute value.
How do we do that in here?
Math, and then go over to number.
That's what I'm supposed
By the way, they don't really take off if you put equals versus approximately equals, kind of give that you're rounding anyway. This is perfect notation, by the way. If you put this on the test without actually writing what V is, that's cool, but only if V is defined somewhere. If you have told them, or if they have told you what V is, then you can just write VOT, okay? The other way to do this one would be to split it into 2 integrals. One going from 0 to this, and then the other one going from this to 3, and then putting those 2 areas together. But the smartest thing to do is just slap absolute value and it gives you the total distance. So what do we get there? This is also a Math 9 question, not Math 8, but Math 9. 4.3338, so 334.
Yep.
All right, good. 4.334, what do you think? How many points?
1.
1. Yeah, that's it.
It's a nice one.
Yeah. So now we're up to 6. That's assuming that we counted this one as 2 points. If we did 3, then 2, then 1,
Let's see.
is the last one 3 worthy or should we give an extra point somewhere else?
Greatest distance, that's your.
During the time interval from 0 to 3, what is the greatest distance between the particle and the origin?
It wants the.
Show the word that leads to your answer.
wants
Okay.
the particle min, it wants the position min or max.
All right, now, we can do this.
Just take an antiderivative, then plug into the calculator, see where the min or max is. Or the local min and max is from that point.
Correct, and I actually know what the local mins and maxes are
Because we,
because
You know what
of what we
velocity
did
equals.
here.
yeah.
Okay, so the min or max is gonna occur either at the stopping points or that one.
So just plug them into the antiderivative. So we just plug into the antiderivative, or you have to just take the antiderivative and then
Here's the rub.
can we do from 3 to 3?
Well, here's the rub. Let's do time 0. Anybody know where the particle is at time 0?
0.
No.
1. They told you that.
Oh.
They basically, you know, when we take an antiderivative, we get that plus C thing?
That's the plus.
They're telling you how to get the plus C, that's basically your plus C, assuming that when you plug in 0, you get 0, which you do, okay? So here's this one. All right, now, I'll be very impressed if you can tell me where's the particle here? Or here, either or. Okay.
Let's see,
Yes.
there.
By the way, this has nothing to do with it, because that's doing positive area, that's moving left, right, whatever, so that's not really gonna help you much at all.
So,
Alright, I'm gonna be impressed if you can tell me where the particle is at that time right there. I'm gonna plug mine in, see what I get, and then compare it to yours.
What's going on?
Okay. What did you get?
wait, so,
I would just like to know where is the particle at time 2.507?
I don't know how you did that with plugging the calculator, that's what I want you to figure out. I know there's F min and F max. That's useful, not for this.
Oh, wait.
Okay, wait, what if it had started at the point 0, 0? What would you do?
Get over it.
What if I had started this at the point 0, 0, how would you figure out what his position is?
Plug that into, not plug into.
Plug into the antiderivative. Go from 0 to 2.507 and get a number.
Plus one.
And then add 1 to it, right? Since it starts at 1, we just shifted up 1 unit. So this one shifted up 1 unit is negative 2.265. All right, what about 3?
How are you using,
Did you-
how do you get your antiderivative?
Hold on.
Math 9, 0 to 2.507.
Oh, it was 2
Oh, that's right.
P of T.
So that just gets you to the point of, okay, I didn't know you could use it like that, okay.
It's all negative, right? We know that that whole area right there is all negative, so it's all traveling in one direction. There's no turnaround, there's no lost area.
Okay.
By the way, this answer without the plus 1 is negative 3.265, so it moved left about 3.5 from 1, which puts it about negative 2.5. Okay, how about S of 3? This one's pretty easy. Start at 0 and go to 3. Okay, without the absolute value, if you just hit second enter and bring up the last thing you typed in, that's the easiest way to do it, and then just change it to 3.
No, that did not work. I don't have very much luck with these.
Not too good with that, huh?
Negative
Huh?
0.197. Negative 1.197. That's with the plus 1 thrown in there, please. That's with the plus 1 tacked on. So, let me go back and read the question, make sure I'm answering what they asked. During the time interval from 0 to 3, what is the greatest distance between the particle and the origin? Show the work that leads to your answer. This is
Negative.
a lot of good scratch work. No, not negative. What is the greatest distance between the particle and the origin? 2.265 units. Happens to be to the left, but it's 2.265 units. Does that make sense?
Yes.
The greatest distance is, and I would write that whole sentence, the greatest distance between the particle and the origin is 2.265 units. Okay, where am I showing my work?
In
okay? That's me telling you, this is where he started, this is where he was here, because that's from here, and this is where he was at the end. They will know what you meant when you did that,
Yeah,
because we found it here.
so,
So that's why they asked
it
it.
should be about 7 minutes for this entire question.
You have 15, if you look at it and know how to interpret it
Wait, now,
from beginning to finish,
that's 2, that should that,
I honestly think we would be good at 3 points for A, 1, 2, 3.
4,
What do we say, hang on,
I think we said 2 for
Two
that
for
one.
that one, I believe.
what did we give it
One, maybe
to?
two.
1 for the,
One for the number, one for the.
One for the number and one for the reason?
Yeah.
Something like that.
oh, no, it was
Mhm.
4,
I think we gave, this one we gave 1 point.
that we gave 1 point, that's 2 points.
This one, we're
That-
giving,
1 for answer and 1 for testing all points.
alright, so we have 7 points accounted for and then 2 that are at large, okay?
Probably 1 on B and then maybe a third one A.
Let's see how they graded it. Part A, 2 points. 2 points, 1 for finding this,
We gave that 3, didn't we?
we did, and then 1 point for
This.
this. You didn't even get a point for it. You needed to say that it was negative, you didn't even have to find the number, you just had to say that it was negative,
Yeah.
okay? You can't justify it without plugging it in. If you plug in 2, that's -3, the sign value never goes above, well, at that particular spot, it's going to be positive. Sign, what do you do, when you plug in 2, 2 squared is 4, 4 divided by 2 is 2, sine of 2 is somewhere in the second quadrant, if you knew that, it's radians, okay, so it's right there. That, you could have said that's gonna be negative. So 1 point, 1 point. Part B, is worth 2 points. 1 for only including this, by the way, that is the square root of 2 pi, if you're interested.
Really?
Yes. And 1 point for the sentence around it, for justifying it, because this is where the sign actually changed.
Wait, it's the what? Square root?
Square root of 2 pi,
Huh?
it's easy to do. If you're trying to set this equal to 0, you know
Oh,
that this
of
gives
2
you
pi,
negative
I was-
1. This, you know sine is equal to 0 at 0 and 2 pi, so you would just set this equal to 2 pi and
For some reason I was hearing it the square root of pi squared, I'm like, what?
2 pi. Alright, part C, the one we gave 1 point,
2 points.
3 points. Number 1, okay, number 1, limits, so correct limits of 0 to 3.
Absolute value.
Number 2, correct setup, absolute value of v of t, and
Answer.
number 3, we'll call the
That's,
answer. I know, right, that's sick. That is the easiest 3 points I've ever seen on an AP
that
question.
took us like less than a minute.
Yep, and the last one was worth 2 points.
1 for the numbers and.
One for the
1
justification
for
of
the
the
number,
number.
hang on.
1 for plugging everything.